Section 2.1, Linear Equations in One Variable. Objective 1, Solve linear equations. An equation is a statement that two expressions have equal value. That means left and right side equal each other. And solving algebraic equations involves finding values for a variable that makes the equation true. So when we solve, we're just trying to find what that variable needs to be to make the left side equal the right side. So for example 1, we want to get x by itself. Then to get it by itself, we want to do whatever's next to it. We want to do the opposite of it. So if we have x minus 4, the opposite of minus 4 is plus 4. And we add that to both sides to get x equals 11. Now, something you always want to do is check your answers. Not so much with what we're doing in 2.1, but it's good to always just check your answers, because later on in the semester we're going to get to something where one of the answers is incorrect, or and so on. So just make sure you check your answers. You can do this in your head. 11 minus 4 is 7, so you're good to go. That is an answer. Now moving on to example 2. We have negative 8x equals 64. So we have negative 8 times x. The opposite to get it by itself is division. So we're going to divide by negative 8. So when we divide by negative 8, we get x equals negative 8. And if you plug that back in, it does work out. Now moving on to example 3. Now we have multiple things going on here. Let's just take a look at the left side. If we take a look at the left side, we can combine like terms. You always want to combine like terms before you start moving stuff over. So we combine like terms. We have 4p and negative p to get 3p. Minus 11 equals. And then we can go ahead and combine on this right side the numbers. So we have 2 and negative 20 to get negative 18 plus 2p. Now that we have combined like terms and made it as small as possible, we're going to start moving stuff over. So I'm going to subtract 2p to both sides. So we're left with p minus 11 equals negative 18. Now all we have to do is move that 11 over. So we add 11. We have p equals negative 7. So anytime that there's just a bunch of stuff going on, make it as small as possible, and then start moving your variables and your constants over. Example 4, we have 3x minus 7 equals 3 times x plus 1. So anytime, remember, we have that number outside of the parentheses, we need to distribute it. Draw your arrows. So after we distribute it, we have nothing on the left side, we didn't do anything. So it's 3x minus 7 equals 3 times x is 3x. 3 times 1 is 3. Now, just like before, we need to get the variables on one side and the numbers on another side. So we're going to subtract 3x. What happens to the x's? They cancel out. So since they cancel out, we have negative 7 equals 3. Negative 7 never equals 3. That's impossible. So because that's impossible, it's not an equation. It's no solution. So anytime the one side doesn't equal the other, you can't do it. It's impossible. So it's always going to be no solution. Now example 5. Anytime we see those parentheses, we absolutely need to distribute. So we have 5x minus 5 equals 2 times x is 2x. 2 times 1 is 2 plus 3x minus 7. So you see this right side, we have a bunch of stuff there. Let's combine like terms where we can. So we get 2x and 3x is 5x. 2 and negative 7 is negative 5. Let's take a look at this equation. We have 5x minus 5 equals 5x minus 5. They're the same exact thing, right? So do those technically equal each other? Well, yes, they do. So what this means is that it's infinite amount of solutions. So when the two sides are the same, it's infinite solutions. So the difference here is when the two sides don't equal each other, where it just doesn't make sense, it's no solution. And when the two sides are identical, it's infinite amount of solutions because they're the same exact thing. So that's it for 2.1. Just solving for x. I know you guys are really good at it by now, but just a quick refresher, just in case it's been a couple years. And the next video will be 2.2.